All right, number 11, we have some geometry questions. We're going to finish out a portion of this program with geometry, okay? A few questions on geometry. Got quite a few on the test on geometry, so let's talk about it. All right, number 11A, we want to know the perimeter of a regular heptagon with 13 centimeter sides. First of all, remind you to study the figures, right? Heptagon, hexagon, octagon, nonagon. There were several of those. Remember those. What's a heptagon? How many sides? Hexagon is 6. Octagon is 8. Nonagon is 9. Heptagon is 7. So we've got 7 sides. So the perimeter is just the measure of every side. So it would be 7, 7, 13. 13 7 times. 13 times 7. 91. 91 centimeters. All right, here's another one. Find the measure of each angle of a dodecagon. Well, just a decagon is how many? Decagon is 10, and do means basically 2, so it's 2 plus 10, 12. Yeah, 12 sides. So I want to know each angle. Here's another formula, though. Before we can get each angle, we have to get the sum of the angles. How do I get the sum of the angles? Remember? Well, I take the number of sides minus 2, n minus 2, let's call it, times 180. Remember we did that with the triangles. There was always 2 less triangles. So I take the number of sides minus 2 and multiply it by 180. So in this case, it would be 12 minus 2, so it would be 10 times 180. It's 1,800. And so then each angle, well, if it's a regular dodecagon, each angle is split up equally. So each angle would be 1,800. How many angles do I have? Well, if I've got 12 sides, I have 12 angles. So I divide by 12. 150. I believe that's what that is. With me on that? All right. We're in the geometry. There were quite a few formulas. Here's another one. You've got crossed lines like this with some angles showing 2x plus 4, 4x minus 24, and I even designated these A and B. Let's see what you know about those. But the ones I have with the x's, what do I know about them? What kind of angles are those? They're vertical, right? They're across from one another, so these are vertical angles. The 2x plus 4 and the 4x minus. And what do we know about vertical angles? They are equal. Vertical angles are equal. So we have 2x plus 4 equals 4x minus 24. Now, there were some times when we added the angles and got 90 if they were a right angle, right? If they're a straight angle, you add them and get 180. But if they're straight across from one another, they're equal. Okay, so solve that little algebra there. Subtract the 4x, this is the way I do it. Subtract the 4x, so it gets me negative 2x plus 4 equals negative 24. Then I can subtract the 4 and get negative 2x equals negative 28. Divide by negative 2, and I've got x is 14. And so the 2x plus 4 angle would be, if I know x is 14, what's that? 2 times 14 is 28, plus 4, 32. 32 degrees. Then the 4x minus 24, well, it better be the same. If I do 4 times 14, that's 56, minus 24, yeah, that's 32. But let's go ahead and mention A and B. What about A's and B's angle? They're equal too, but what are they? How can I get those? Well, if I know this one's 32 now, then can I figure out what that one is? Because aren't those supplementary, the 32 and the A? They're 180 total. So I can do, for A, I can go 180 minus the 32, and that's the same for B, but be 148, and then B is equal to that. It's 148 also. So there's our 4 angles. Question. These 2 angles form, this angle and this angle form 180, right? Half, all the way around is half of 360. So that's where I got the 180. Number 3, shaded area. Okay, I'll write it down here. Drawing on the paper is much better. Okay. 45 centimeters, 90 centimeters, and this is 60 centimeters. And it tells me the circle is 100 meters across. 100 centimeters. 100 centimeters across. Okay. How do I figure out this shaded part here? Well, what I've got, of course, I've got a circle with a piece of it cut out. What piece shape is that? Trapezoid. Which brings up another thought, and that is, be sure to remember those: area of a circle, area of a trapezoid. There's others: area of a triangle, area of a parallelogram, rectangle, square. You need to know those.
All of them?
All of those, yeah. Circle, trapezoid, especially the ones you are not that familiar with, probably. You know, the length times width is a rectangle, square, side times side. You know those, so it's just a few. But here's one of them, 2 of them. So how do I get the area shaded? Well, I take the area, to get the shaded area, I'm going to take the area of the circle minus the area of the trapezoid. That's the way I do it, right? What is the area of the circle formula? Pi r squared, yes. Pi r squared. So I take 3.14 times the radius squared. Now, what's the radius of this circle? Well, if it's 100 centimeters across, the radius is not 100. Across is the diameter, so the radius is half of that. Be 50. 3.14 times 50 squared. What does that give you? 3.14 times 50 squared, 7850. So the circle, 7850. 7,850. What about the trapezoid? Area of the trapezoid. What's the formula there? Remember? It's a half times big B plus little b times the height. Where big B and little b are the parallel sides, right? In a trapezoid, you got parallel sides. So the big B and the little b are the lengths of those parallel sides. So I've got 45 and I've got 90, so it'd be 1/2 times 45 plus 90. And then the height is through the middle there, 60. So what do we get there? It'd be 135 times 60 divided in 2. I get 4050. 4050? With me on that? So that's what I would subtract from the circle. So that would give me, what, 3,800? And might as well mention the units. What are units for area always? Square units. So this would be centimeters squared. And so, last but not least, number 14. Has a three-dimensional figure. "15 inches tall," it is, top to bottom, and then 10 inches across here, but here's the base expanded out a little bit. 10 inches and 8.5 inches here. So these are the formulas that you don't have to memorize, but just know how to be able to work with them. We had cylinders, we had spheres, we had prisms, pyramids, boxes, cubes. Which one is this? Well, what's the one that meets? This is the pyramid, yeah. This is a pyramid. And so I look up the formula on the sheet there. The volume is 1/3 big B times H, where big B is the area of the base. And big B, the formula for it will vary depending on what size, because sometimes the base is a square, sometimes the base is a trapezoid, so we could use this formula. The formula for big B can, but in this case, what is the base area? It's the area of a triangle, right? And so I would use the formula for area of a triangle. Area of a triangle is 1/2 base times height. So big B is going to be 1/2, the base is 10, and the height is 8.5. So I'm going to take 1/2 times 10 times 8.5. 10 times 8.5 is 85. And take half of that, 42.5. But that is not the answer. That's just part of the formula. The volume is 1/3 that, 42.5, times the height of the pyramid. The height of the pyramid is the 15. Multiply that by 15. So I take 1/3 times 42.5 times 15. That gets me along about 212.5 volume. And the units for volume are always cubic. Inches cubed. Now I didn't ask surface area. I didn't do surface areas of pyramids, but we did have some surface areas, and those are listed. The ones we did in class are listed on the sheet, but just remember on the surface area you use square units, its area. All right.